Um, Today I'm going to present my project together with Ivar and Michiel about energy efficient dwelling by urban mine biomimicry based facade renovation. So first of all, my name is Ana Luíza. I'm a civil engineering student from Brazil, and currently I am working as an intern in the Drive Zero project in the Netherlands. And throughout my studies, I developed a vast interest in building sustainable and circularity. And that's what I'm going to talk about today. So let's get started. As we have beforehand, buildings represent nowadays 40% of all the operational energy consumption in Europe. Furthermore, more than 50% of all the extracted materials are attributed to buildings. And construction waste accounts for 25 to 30% of all the waste generated with its collateral embodied energy. Another point to highlight here is that the life cycle energy performance of the building corresponds to the total embodied energy and total operational energy that the building consumed during its lifespan. So here, that's our challenge. That's our current dwelling in the Netherlands. This dwelling was built in 1965 in a large scale in the Netherlands. So probably if you are walking around the Netherlands, you're going to bump into one of these houses. And these houses have no wall or roof insulation, and it brings a really high energy consumption. So the objective of this study is to develop a circular solution to reduce the total life cycle energy performance of this typical dwelling in the Netherlands by facade renovation. The proposal of the study consists of three layers. The first layer is the first skin, and we are going to use wooden frames with insulation to reduce the energy consumption during the winter situation. Then we have the air cavity, in which we have the natural ventilation that is going to help the thermal comfort and reduce the energy consumption during the summer situation. And the second skin facade, that inspired in biomimicry, we have the skin protection plus the solar panels. This proposal is based into two strategies. The first is urban mining and the second biomimicry. Firstly, we have urban mining. Urban mining consists of recovering the waste materials from the urban areas. And here we have the scheme with all the materials we have available in the region called Parkstad in the Netherlands. And among all these materials, I want to focus in the wood. For the wood, we have 14 kilotons. And the advantage of using the wood is that it's energy recovery, it's easy to separate from other materials, and it has many different uses like structure, insulation. Inside the concept of urban mining, we are going to use this concept of urban mining in three parts of our study. First, the insulation material, the wooden structure, the wooden beams, and the cladding materials. So firstly, we have the insulation. With the wood beams that we have from the Parkstad region, we have the sawdust. And with this sawdust, we are going to make the wood fiber insulation. The wood fiber insulation has really nice properties. The thermal conductive is around 0.039. The embodied energy is low, is around 10.8. And the embodied CO2 is close to 0. In the right image here, you can see how we plan to place it with the wooden beams plus the wooden fiber insulation. So the second part of the concept of urban mining that we are going to use is with the wooden beams. For the wooden beams, we have here in the left side the beams from Parkstad. And with these beams, first we are going to use that for the wooden frames for the insulation. We cut it in the middle and use it as the structure for the wooden frames. The second use for these wooden beams will be to make the cladding material for the open joint ventilated facade. We cut it in 4 parts and use it as a cladding material for our open joint ventilated facade. The second strategy that we are going to use in this study is biomimicry. Biomimicry consists of learning and mimicking strategies from nature to solve human design challenges. As you can see here in the left side, we have this cricket, and inspired in the opening system of this cricket, we developed our open joint ventilated facade idea. To bring some reference for our proposal, I'm going to explain about this article found that it's called Numerical Comparison of Thermal Behavior Between Ventilated Facades. And here is one study from Poland in a summer situation. And here I would like to highlight the standard facade and the open joint ventilated facade. That during summer, the temperature difference between the first layer and the second in the ventilated facade is almost 28 degrees difference. So inspired in this case, in another previous study, we created our scheme draft. Here we have our existing situation that consists of 2 brick layers with no insulation. And here in the right side, we have our proposal, the Drive Zero proposal, that consists of 1 brick layer, wood fiber insulation, air cavity, and the wood cladding for the open joint ventilated facade. The methodology we are going to use is to analyze and compare this solution in terms of embodied energy and operational energy. What means that we are going to analyze that in terms of life cycle energy performance. And to calculate the embodied energy, we are going to use the Revit plus the ICE database. And to calculate the operational energy, we are going to use the Revit plus the Insight plugin. After doing all the simulations, we are going to make some prototypes to have the results validated. As you can see here in the next slide, here we have the mock-ups, the prototypes that we are going to test in real situation. First, we have the existing situation, then we have the insulation with the wooden structure, and the third prototype will be the Drive Zero proposal with the insulation, the air cavity, and the open joint ventilated facade. The expected results is a reduction of the life cycle energy performance of around about 70% over the lifespan of 50 years. And with the solar panels, our life cycle energy performance tends to be a life cycle zero energy. As you can see here in this graphic, here in the left side, we have the current state. In blue, we have the operational energy. And in orange, we have the embodied energy of the current state. This in the middle is the proposal, the expected results for our proposal. And here in the right side is the ideal scenario of a circular renovation. And as I said before, the result that we expect is about 7% reduction. Thank you so much for your attention. If you have any comments, any feedbacks, feel free to contact me. And I think we can have a really nice discussion about this topic. Thank you so much.
Wow, thank you very much for your impression.